Students, good evening, good night, happy holidays. Enjoying your holiday so far? You have 3 more days, wait, 4 more days to enjoy your holiday. So enjoy it to the max, okay? Is it loaded with homework, your holidays? A lot of homework, not you guys? Yes, good. I'm rushing. Good. Yeah, 5 Chinese essays in a day. Good. Slowly train. Okay. All right. Now, you're playing, no desire. Slowly, like, just copy ni, just copy. All right. Hopefully, by writing something, you get to learn. At least learn something during this holidays, instead of letting your mind just go zoom empty, right? Yeah. So fast Wednesday already, enjoying so better. Okay, live the moment, enjoy the moment. Okay, hello everybody. Let's start. So let's do a short recap of what we learned last week. At least you remember something. So last week, we learned about electrical circuit, and electrical circuit have three important components that you need to know, three important units that you need to know. First one, we call it current. Second, called voltage. And third one, we call resistance. Do you still remember what that is? Yeah? So electric current means how fast, right? There's a battery over here, here. All right, so current means how fast my electric charges move. That's current. Yeah, we represent with I. Voltage means how much is my push? How much am I pushing them to move? How much am I pushing them to move? That is voltage. Resistance is the nature of the wire, because the wire have what we call a resistance to slow down the movement of current. Understand? So resistance and current is always opposite. So resistance is high, then I have lesser current to flow down, correct? To flow through, so I'll be slower. So these two are always against each other. Understand? So, and we learn about these three. We can, if I give you 1 and 2, you can find the other 3. Or if I give you 1 and 2, you can find the other 3. And what is that? That is a master formula known as Ohm's law. V equals to IR. By the way, I did not mention last week, it's called Ohm's law. All right. Ohm's law is V equals to IR. So for today's class, okay, no matter how I extend my electrical circuit, because last week was level 1. Today, we are going to go level 2, level 3, level 4, level 5, and level 9. So what's happening over here? No matter how my electrical circuit will be, whether I am like this, or I extend another wire, or I extend another wire out, or I extend another wire out, or another wire out, with a light bulb over here, light bulb over here, light bulb over here, light bulb over here, it doesn't matter, or some kind of symbol over here, it doesn't matter, because they will all, at the end of the day, will follow back, will all bow down to this master formula called V equals to IR. Understand? So there's a master V, there's a master I, and a master R. So what do you mean by that? So let's look at today's class. So there are two types of electrical circuit. Okay, today we'll look at series circuit. For those who have learned RBT, is litar bersiri, and this is called litar selari, parallel circuit. Now, series circuit means the components. What's the meaning of component? Light bulb, component law, battery, component law. Understand? All of these are components law. Okay, so the components are connected end to end. So there's only one path. There is only one path for current. So if I'm an electrical charge, current, I will only move one jalan only. Understand? This is a series circuit. Now, whereas for parallel circuit, there are more than one branch of path, and there are electrical components in each branch. So what does that mean? So imagine if this is us, electrons. Okay, what is this? Okay, so these electrons, they can move. Let's say Dylan move. Dylan can choose to enter into this path. Or the next round, Dylan can choose to enter the second path. Understand? So there's more than one path for you to go through. And every path, you will have one electrical component. Understand? So with this, let's go into a series circuit. Do you remember just now? We learned V equals to IR as the master. So the whole circuit, don't care how complicated, there is a master V, there's a master I, and there's a master R, right? Now, what happens is this. Look here. This is 2 ampere. 2 ampere means the current, right? The current that comes out is 2 ampere. Now, my turn to ask now. If I put an emitter over here, how much reading of ampere would I get over here? Next, the electricity move here, current move here. How much current is here? When I move up here, how much current is here? So for series circuit, there is a formula, right? Series circuit is for the current. This I is master current, the biggest of all biggest current. According to this law, it states that all the current I1, I2, I3, what is this I1, I2, I3? This one, current 1, current 2, all right, current 3, if I got more emitter, current 4, 5, 6, so on and so forth. According to this rule, is everything is the same. So if I supply 2 ampere, zoom, electricity come out, the 2 ampere will be recorded the same for every single time. Understand? So according to here, what are the readings of A1, A2, and A3? Remember, A is your emitter, yeah? So what's the reading of emitter? It is all the same. So reading of emitter, A1 is 2 ampere. Agree? A2 is also 2 ampere. A3 is also 2 ampere. That is the reading based on this series circuit measurement. All good? Next up, how about voltage? Look here, my master voltage. Remember, battery always give out the master voltage. Battery push out energy of 12 volt. Boom, 12 volt coming out, right? But when I have, let's say, this resistor, can be a light bulb, can be resistor, can be anything you put. Any electrical component, can be heater, can be oven, can be TV, it can be any component. Let's just keep it simple and put a resistor to represent them. Okay, so when the voltage pass through this resistor will use up some energy. And then here also will use up some energy. So how do we split these two energy? Now, according to the voltage, master voltage is equals to all the voltage passing through my component. So that means this 12 volt, when I push out, it will be split to all my different components, not evenly. Maybe you take 4, maybe you take 5, maybe you take 6. Either way, it will all add up to 12 volt. Understand or not? So what is the total voltage? What is the, sorry, can you please change total? What is the voltage? Cancel this thing. What is the voltage of V1? What is the voltage of V1? Please cancel and change this one. So how much is V1? My master voltage is pushing up for 12. If our friend here uses up 8 volt, how much is this using up? Hello? 12 minus 8 lor. So 4, right? So using the formula, 12 volt equals to V1 plus 8 volt, right? So V1 is 12 minus 8 will be 4 volts. So definitely you will see a 4 volt reading here. It will be split evenly to every component. See, teacher, what if I add one more over here? This one 8, 4. Then this one, you start to see adjustment already. Maybe this one will be 7, this one will be 3, so on and so forth, depending on what electrical items you use. Okay? Lastly, a resistance. Resistance means if I am an electron, I travel along the path of the electrical circuit. How much is the wire or the items pushing me back for? Is measured in ohms. So how to measure? As you travel here they'll fight you for 8 ohm. Your current continue, they fight you for 3 ohm. So the total, the master resistance, total add up all your resistance, add up together is formula is your master. So R is your R1 plus R2. So my total resistance is R1 plus R2, which is equivalent to 3 ohm plus 8 ohm, which gives you 11 ohm. Agree? So that is what it means. That means if you were to walk in the electrical circuit, you have to face a total of 11 ohm fighting you back, slowing down your movement. So this is for series circuit. Quite easy, right? Series circuit, formula ni ma. Now the worry is whether you remember the formula or not during exam. Okay. Let's go to advantages. Now this one, put a star here. This is a very common question that they will ask. What is the advantage of a series circuit? Advantage, good thing. Okay. Let's go into something that makes more sense. Okay. The current, do you notice here? Every component receives the same amount of current. Means what? Highlight, same amount of current. What does that mean? It means if I am a light bulb, all right, when I use 2 ampere, these two brightness, remember, current tells you how bright or how dim it is. Okay, so when I put 2 ampere, these two will be the same brightness. Teacher, will it be one brighter, one dimmer? No, it will not be. It will be both same current. Example, Christmas lights. You know Christmas lights, right? Christmas lights, you put on your Christmas tree, correct or not? All these lights, for those who celebrate Christmas, you have all these what we call fairy lights. All of them is same brightness, correct or not? Yeah? Okay. Next up. Good thing is one switch can control all components. Highlight. One switch control all the components. Meaning, let's look here. When I arrange things in a series circuit, if I put a switch over here, when I close the switch, close means connect, got electricity. Okay. When I close the switch means I turn on. All right. This light all will light up. If I turn it off, everything will switch off. So easy lah. Let's say if it's your house lighting. All right, your house lighting, imagine this is your floor and your ceiling. Light number 1, light number 2, light number 3. So you go to your wall, you off the switch. If all of these 3 turn off at the same time, that means they're all connected in series. You see that, right? Yeah, all connected in series. So everything off one shot. Okay, so next thing over here, the higher the voltage, the higher the current. Means what? That means if I increase my battery, my battery power, it will push more. Then my electricity will be brighter. Okay, so that's at least the first two is important. Now let's go to the second one. This is the disadvantage. So please highlight disadvantage. This is advantage. The bad thing is this. When one component is spoiled, one of them spoiled, the other components cannot function. What does that mean? It means that if, let's say, this light bulb spoiled already, then my whole circuit can use that, but cannot light up this one already. Okay, because the current go here and then Z stop already. Cannot continue and light up the next one. You understand that? Yeah, so that is the bad thing of arranging things in a series manner. One spoil, the others cannot function. Now remember, this is where students always get wrong. You know why? Students say, what's the disadvantage? Students say, when one spoil, the other one also spoil. Incorrect. Understand? This one did not spoil. If this one burn now, let's say this one burn already. This one doesn't mean it is burn. This one means cannot function. That means still working. For that moment cannot work only. 明白吗? You see the difference? Yeah, be very careful with your words. Yeah. Next, the bad thing is you can control all, but the bad thing is if I want to control them individually, I want to off this light, I don't want to on that light. So sometimes you face that problem. I don't know whether you face it in your home. Okay, I want this light on, this light on, this light on. I don't want all to on at the same time. If they're arranged in a series, you cannot do that. See, components cannot be switched off or on individually. As a single light cannot. My house, one light each own their own switch. Okay. Okay. Next thing. If you notice the resistance over here, okay, when I add more light bulb, my resistance will increase. You all don't know, okay, just to let you know, let's say, I have one light bulb over here, one light bulb, okay? When I connect them, this one shine for, let's say the brightness is six lines, okay? But if I pull in another light bulb into this picture, these two supposed to be 6 supposed to be equal, but now I introduce a new light bulb, they cannot shine for 6 already. They increase the resistance already, so what will happen? Maybe this one shine for 4. Remember, they must be the same. So the two brightness now have to share between all of you guys. Understand, right? Yeah. So you get lesser current. You add more lights, it will be dimmer. Add more lights, even dimmer. Understand? Because you add more lights or add more whatever component, you're increasing the resistance. More component, more resistance. More resistance, the light will be less bright. Understand? Yeah, so current tells you how bright or how not bright. That's all measured by current. Okay, ma? Next up. Recording of this is available, so you can get it. I know some students will tend to forget this. Don't worry, you can watch back the recording. All good? Thumbs up if you're okay so far. Now, let's go to a parallel circuit. What is a parallel circuit? There is more than one path for you to walk. You can walk here, you can walk here, correct? No? You can walk many paths. Yeah. So let's start. What are the readings of A1, A2, A3? What does it mean by A1, A2, A3? So always ask, master formula is this, correct? The I, the master current, always come out from the battery. So this is the master giving out 3. I'm giving out 3 at one time. But look over here. According to this formula, the master in a parallel circuit, it will not be like this. It's not the same. It's not the same. They are split. Split to 2 different ones. So that means if 3A come out from here, 3A, 3A, 3A. 2A will move here. Then how many A will be here? Will be the remaining 1A. Understand? Say, teacher, how I know whether 2A come here or 1A come here? It's depending on what component you use. Maybe you use a light bulb here. Maybe you use something, other things here. So some will take 2A, some will take 1A. It really depends. Understand or not? Yeah? So, question asks you now, what are the readings of A1, A2, A3? Let's look. A1. A1 comes from where? Notice here, A1 is not inside this line. A1 is directly after the battery. That means it's near the battery. That means it's taking the battery's current. So which is how much? 3A. Understand, ma? A1 is taking from the battery, fresh from the battery. But if 2A enters here, my A3, A2, A3 will have 2 ampere reading. A2 will have the remaining 1 ampere reading. Understand? Yeah, so it's basically like sending 3 of you. Zenyi, Max, and Dylan. 3 of you go out, go out, go out. Then Dylan and Max decided to go this way. And then Zenyi will be left to walk the other way. Understand now, for example? Can? Yeah? Now, next thing. What are the readings of V1 and V2? What is V1, V2? This voltage, remember voltage, we have to pull out, right? Parallel, right? Voltage to measure, we have to pull out. So basically asking you how much voltage is here and how much voltage is passing is here. All right, so for voltage, the energy is the same. That means master V will be the same as V1, also will be the same as V2. Okay, so what are readings of V1 and V2? According to formula, V1 will be 20 volt. 一模一样. No difference. The energy will still be pushed out for 20 for both circuit. Okay, for those who are wondering, teacher, how to set up this one? Okay, I'm going to draw out for you to show you. Let's say I got 2 batteries here. To connect to the first one, I will have a wire from here connect to the first one. All right. Second one, it is actually not here. It is from the same battery, I pull out another wire to go back to the same battery. This is how it's arranged. That's why when the battery push out 20, they will push out 20 to both electrical circuit. Okay, ma? Okay. Now, resistance. Ready? Question asks you to find the total resistance in the circuit. How do I find total resistance? If I walk here, 10 will fight me. But if I walk here, 5 will fight me. So on average, how many is fighting you? That means on total, if you just walk both circuit, at the end of the day, if they even out, how much is fighting you? So is there a formula? Yes. Formula is this. Can you please check over here? I got an error. Please write 1 over R over here. Formula is 1 over R equals to, that means 1 over main boss, R, equals to 1 over R1 plus 1 over R2. Teacher, I'm confused. Let's do this. Total resistance, let's write down the formula first. Again, total resistance means the master resistance here. Okay, all good? So let's find the master. What is resistance number 1? They are fighting back for a 10 ohm. Agree? The other one, they are fighting back for 5 ohm. So can you please use your mathematics and calculate for me do it in a fraction. I want your answer to be in fraction. Calculate what's my answer here. What over what? Do it in fraction, please. Let's say anyone. Mathematics, basic mathematics. 1 over 10 plus 1 over 5 is how much? Is it 3 over 10? Am I correct? Correct? Times 2 times 2 because I want to make the denominator the same. Correct or not? So down there will be 10 ohm. What's up there? 1 plus 2. So 3. Agree? Correct? So what is my resistance? My resistance is not 3 over 10. Resistance is R. This one is 1 over R. So what do I do? You got two ways. Now, I will explain to you your old way and I'll show you my shortcut way. Okay? Your old way, your mathematics teacher will ask you to cross multiply. Agree or not? 10 equals to 3R. You learned this already? Linear? Yes, no? Got learn not? Right? And then R is 10 divided by 3. 对吗? Okay, that's what your maths teacher teach, right? Now, your science teacher will teach you a faster way. You 1 over R, 3 over 10, you just have to flip, and the other side you flip. That's all. You flip 1 over R, you get R over 1. R over 1 by height. R law, same as R law, correct or not? 10 over 3, you flip, 3 over 10, you flip, you get 10 over 3. You see, same answer. Right? You just have to flip both sides. You get 10 over 3. And 10 divided by 3 is how much, students? Calculator? Hello? Three point 33 ohm. Understand? Can? Can or not? Okay. So who do you think got lesser resistance? So imagine, I'm just to show you, okay? You see, so what does this mean, 3.33? It means that if you are an electron, when you travel the whole circuit, you fight 10 and then you fight 5, but at the end of the day, total up, you're only fighting 3.33 only. Unless, okay, I mean, different with, imagine if I put these two, I put 10 and I put 5 over here. All right. So if like that, no choice, you are always forced to fight against 15. So if I arrange them in series, you are fighting a very high resistance, 15. But imagine I use back the same 10 and 5, but I open up another wire down there. Do you see how much you have to fight? So much lesser. All right, not 15 already. Yeah, 3.33, which is nearly 5 times lesser. Just to show you a perspective over here. Okay, so it's always better if you want less resistance, you arrange in parallel manner. So advantages of parallel circuit. First one, components can be switched off individually. What does that mean? That means, 在这里, I put a switch. Here, I put a switch. Correct? If I close this switch, then I can turn on this light. Right? If I close this switch, then I can turn on this light. You see that or not? So I can control every single wiring. I can put a switch there. That's a good thing. Next, when one component is spoiled, if one spoiled, guys, if one spoiled, will it affect the other one or not? Will it affect the other one? Yes, no? If this one spoiled already, the electricity say, oh, I don't go here, I go here. So this one can still function. Understand? Huh? Yeah, so the other components can still function as not. Understand? Yeah. Next thing, disadvantage is when I give out 9 volt voltage. Okay, I give out 20 volt. Okay, 20 volt over here. Then this one will use 20. This one will use 20. If I give out 9, this one will give out 9, 9. It is different from this one. This one, when I give out 12, I will split. Correct? I can actually adjust. If I make 9 here, then this one will take 3. So at least I can adjust the voltage. You take how much, you take how much, you take how much, you take how much. I can adjust. But in this one, I cannot adjust. Voltage of across each component cannot be adjusted. Okay? That's the bad thing about this. So far, so good? Now, let's go to latihan and strengthen today's class. Okay, let's do last week's homework first. 1 page only. So a lot of you text me, teacher, I don't understand, never label. For you to figure out, ma. So ampere, current, ohm, resistance, volt, voltage. Agree? It's easy. Next, diagram shows an experiment to study the relationship between current, voltage, and resistance. What is component Q? Q, go back and check. It is actually a variable resistor. What is the function of P and R? So teacher, but they never put what is P, what is R. So we have to go back and check where here, right? They purposely don't tell you what's PR because you learn, all right? The one that is arranged here, parallel, is always a voltmeter. The one arranged here is always an ammeter. Understand? So this is a voltmeter. This is a ammeter. So state the function of voltmeter. Voltmeter is to measure what? P. Okay. P measures potential difference between 2 points. Still, what is that? In other words, P measures voltage. But at this level, since your textbook replace the word voltage with potential difference, we use the word potential difference. Okay? In a circuit. How about R? R measures electrical current in a circuit. So I'm looking for answers potential difference, and I'm looking for answer measure electrical current or measure electric current totally. Okay, you put electric current, no problem. In other words, it is voltage. All good? Yes, Ken? And Toy, if you're done? Not your head if you're done? Not done yet, so I'm still writing. Okay, based on diagram 1, suggest one way to increase the reading of A. What is A again? A is electrical current. 对吗? How fast I move. Students tell me, if I want to increase the reading of A, that means I'm moving very fast, 5 ampere. But I want it to move even faster, change it to 10 ampere. How do I make my electric current flow even faster? What do you think I can do? Remember, A and something else always work opposite each other. One. So what is the something else? What is the fight back call? What is the fight back call? A is a reading of how fast. What is the fight back call? Hello? What unit, what letter do I use to represent the fight back? What is fighting current? Resistance. 对吗? Correct, not? So students, I'm moving at, let's say I'm moving at 5. I want my number to go up. That means move 10. I want my electric current to move faster. I want my electricity to move faster. Should I bring my resistance higher or should I drop my resistance? Tell me, is it A or is it B? If I want my electric current to flow faster, should I make my resistance stronger or should I make it weaker? If you want to run faster towards me, should I push you harder or should I push you lighter? You're running towards me. You want to run fast. You want to run faster. So should my push be stronger or should my push be weaker? Hello? Hello? So if I push harder, right? Imagine you want to run here and me pushing harder. You can run very fast or not? You cannot run very fast, ma. You will slow down because I push you so hard. So what I need to do is I need to give way. Okay, I don't push you so hard. Then only then you can flow faster. 明白吗? Understand? Yeah. So suggest one way to increase the reading of current. All right. Increase the basically current. So what do? I reduce the resistance. Understand? Yeah. Reduce the resistance of the circuit. That is one. Now, how about voltage? Can anyone tell me what can I do with voltage? What about voltage? Who can tell me? Okay, imagine guys. Now, A is the current. You're moving here. Boom. Go and come back. Voltage is the push. Correct? Voltage is the push. So what do you do to push stronger? You want to push stronger so you move faster? Exactly, Dylan. Add more batteries. When you add more batteries, you're adding more voltage. Correct or not? Add more batteries. Why? Because this increases voltage. And you learned before, when voltage is high, my current will also be higher. I want to, by adding, by reduce this, reduce, okay, no need to buy, that's all. Good enough, this answer. So you got two answers to choose from. All good? Next up, since we learned calculation already, let's figure out this one. Yeah, draw the circuit diagram. Identify each circuit as parallel or series. Before we go further, let's identify first. Look at this diagram. Is this a parallel arrangement or a series arrangement? Hello? P for parallel, S for series. No answer, I'll wait until tomorrow. Parallel or series arrangement? Okay, one of you say parallel. Correct, is it parallel? Look at your parallel arrangement versus series arrangement. This is series arrangement, series circuit, because N to N, N to N, N to N. Understand? Very easy. If you see one wire only, it is a series circuit. Understand, ma? How about this one? Parallel or series? Parallel, one wire, the main one. Then you have a branch out. This is parallel circuit. How about this one? Parallel or series? Ah, very good, Ziggy. Series. Okay, good. Max. Sir. Okay. Agree? Now, next, they ask you to draw the circuit diagram. How to draw a circuit diagram? You know how to draw? So let's look here. Dry cell. Anyone knows what is the what's the symbol for dry cell? What's the symbol for dry cell? This one. Exactly, right? So since it's at the bottom here, we have to draw at the bottom here. We have to follow exactly, right? So how many dry cell do I have? 2. So that means I need to draw 1, 2 over here. Okay. All right. Switch left. How do you draw a switch? So look back. Switch like that. So look at the picture. Okay. So my switch is like that. Like that. Do you know why is it like that? Because it's a closed switch. Next, pull up. I have 3 light bulbs. What's my symbol for light bulb? Find X. So we're going to go 1, 2, 3. And done. Students, without my help, I ask you to now, I'm going to ask you to use pencil. I tell you, some students will make mistakes when this one, but use a pencil and sketch your drawing over here first. You want to use pencil and draw here? No problem. Okay, later you just erase only. All right, so I give you 2 minutes, 1 minute to draw out this one in the form of a symbol. Go. All right, so let's see. I have 3 dry cells. So 1, 2, 3. Notice this is an open switch. This is a closed switch. So it should be like that. Anyone? You are correct or not? No. Did the question manage to trick you? Next up. Correct. Very good. Next up, I have my first line circuit to my first light bulb that connects back here. Second, connects to the second light bulb that connects to the bottom. Yes, I'm correct. Very good. Great job. And lastly, try this. Now my dry cell is up here. So dry cell, correct? Ammeter. Yeah, no space. Wait, Ammeter. Light bulb. Agree. Fun, right? Quite easy, right? Once you know the symbol, it's actually quite fun to draw it. Okay, good. Okay. Now, let's go up here. I want to do this one first with you guys. Let's go to page 7, latihan. Let's go to page 7. Okay, let's try this question. Find the value for 1 and 2. What's the first thing first? Look at the title. Series circuit, correct? Yeah? Let me ask you guys. Look at this one. Who is the master current? What is the value of the master current? Master current always comes out from the battery. What's the value? Hello, hello, hello. Hello, hello. Question give you 了吗 current boy current 是 A ampere something ampere. Okay, so coming out from here, master current is 0.6. Question also give you master current at 0.6. Okay, so find the value of this current and this current. How much is it? Look back and tell me now. Okay, look at this formula. I give you 3 big formulas here. Please check. So, looking at this page, your answer should be 0.6 and 0.6. Do you agree? Yes, no? You know why? Because current in a series circuit will always be the same no matter where I measure. I put ammeter here, I put ammeter here, I'll still get the same reading. Understand? Now, let's go to the next one. If V1 is 2 volts, how much is V2? All right. If your formula, look at the screen and refer to the formula. Guys, I'm only practicing you for level 1. After this, I'll give you a level 1000 question for you to go home and figure out. It's going to take some time to figure out this mathematics. If you're up for the challenge lah. If not, we'll stick to the simple one. So according to the formula, master V will be split to both voltmeter reading. Correct? So if V1 is 2 volts, how much is V2? So 3 given out here, ma? So this is 2, this one should be 1. Understand that? Yeah, so V2 equals to 3 volt minus 2 volt, which is equivalent to 1 volt. Easy. Next up, if R1 is 3 ohm, find R2. If R1 is 3 ohm, find R2. I know this is a bit hard, but let's see who can figure out. I give you a clue. Use V equals to IR to find out. So existing information, you know this is 2 volt, you know this is 1 volt. Anyone manage to find? Got that? Okay. First and foremost, student, let's look. Teacher, what is my main R? Because my resistance number 1 is 3 ohm. This one I don't know how to find. I don't have the big R. What's the total resistance? I don't know. Okay, this one also I don't know. So how to find? Don't worry, step by step. You can find the master R. How do you find master R? You can find a master R. How do you find master R? By using the master formula called V equals to IR. You see that? Total V of my circuit is how much? Total V running through my circuit is our master 3. Agree? Total I running in the whole thing is how much? Our master I. Agree? So with these two, can I find my R? Can or not? This is times R. So is bring down, divide. Toima, agree or not? Can you please use calculator and type out for me? 3 divide 0.6 is how much? Don't write first, I want you to count for me first. Count for me first. Calculator, I need someone to type in the answer. It is 5 ohm. Remember what is this? This is my master R now. So students, can you find the mini R over here? If I'm fighting for 3, how much am I fighting here to give a total of 5? 对吗? Right? So, takes time. So we're going to figure out the first one first. We're going to write this formula in. Okay, V equals to IR first. So 3 equals to 0.6 times R. So R is 3 divided 0.6, which is 5 ohm. So R2 equals to 5 ohm minus 3 ohm, which gives you 2 ohm. This is one way to find it. There's another way to find it. Okay. But never mind. Follow this way first. Okay. So just when you think it's easy, right? Then it gets step by step. Takes time. Don't worry. So far, so good? Okay, ma? So I will give you homework to do these two. All right, copy ini ma. Now let's go to parallel. All okay there? Norfei still alive? Okay. All right. Now, not really. Okay, it takes time, takes practice. Okay. Now, diagram 6 shows a parallel circuit. Complicated, right? Guys, don't worry. Look for this. What can you tell from here? This is the master V3 from the battery. 对吗? Then how much is the voltage that runs on this light bulb? How much is the voltage? That's V1 and this is V2, correct? A is what? Current, correct? This is the master current because come out from battery. This is current 1. This is current number 2. Agree? So first and foremost, state the reading for V1 and V2. I give you parallel circuit formula. Look here. Who can type out for me? What's the answer for V1 and V2? How about Norway? What's the answer? Okay, Zenyi, give the answer already. How about Norway? Apa itu E? E means what? Okay, so V is the same for all of them. Agree? Yeah? So if this is 3, this one will be the same, this is also will be the same. So 3 vote, 3 vote. Yeah, I don't know how to read Chinese. Oh, see liao. Bye. Okay. Write an equation to show the relationship between I1, and I2. So what's the relationship? What's the formula? For I, there, I1 plus I2 lah. Okay? So I equals to I1 plus I2. Understand? Can? Alright. These two, I'll let you do as a homework. Because today we do a lot of calculation. You're going to train your calculation first. Now let's go to the bottom here. Alright. This one sounds fun. Let's go to page 70. We haven't done resistance yet, so let's do resistance. Can. Question. Ask you to calculate the effective resistance. In other words, total resistance of circuit A and circuit B. Alright? So you need to know circuit A is a parallel or series circuit. Parallel or series. So I'm giving you the same thing. 6 and 3, 6 and 3. One I arranged differently, one I arranged differently. I just want to show you like this now. Okay? Who is lesser? Let me ask you now, before we do, let's just do a hypothesis. Which, if you are an electron walking in a circuit, which circuit you have to fight a higher resistance? A or B? Type in your answer. Which circuit do you think you have to fight a lot of resistance? Max say A. How about the rest? If you are walking in this electrical circuit, all right, and all the way until the end here, another one, you walk here, or you walk here, okay? Which one do you have to fight more as you walk the resistance? Okay, a lot of you say A. Okay, don't worry. We do calculation and then we'll see. Okay, so let's start with circuit A first. How to calculate total resistance? First of all, let me ask you. Series or parallel circuit, this one. Type S or type P? Guys, is this a series or parallel? How many? Is there only one wire or is there more than one wire? Max, got how many wires here? 这个是一个 wire. Wire 可以 split 的咩? Is it not? I have one wire here, another wire coming out from here. 对吗? This is only one wire through like that, one straight connecting end to end. This one have to split to 2 branch. So this is a parallel circuit and this is a series circuit. Understand? So how to calculate the total resistance of a parallel circuit? Formula? Let's write down. 1 over R, 1 over R1 plus 1 over R2. What's the formula for series circuit? Resistance. Look here. Add up together, correct? So R equals to R1 plus R2. So easy, this one. Okay, now I give you time. Figure this one out. Okay, find for me how much is my resistance, total resistance of the whole circuit. If I put a 3 ohm resistance here and a 6 ohm resistance. So when I use these two, what is my total resistance they are giving? All right, give you time to do now. Norfei, you give answer for, okay, let me see. Norfei and Dylan give answer for this. Max and Zenyu give answer for this. Flip at the notes and see. Okay, if you need help, I give you a guide already. Now, give you a guide on this page. Okay, Max is easy, right? Max and Zenyi like straight away immediately give answer already. Too easy already. 3 ohm plus 6 ohm gives you 9 ohm. How about this one? One over 2 ohm. Okay, let's see. 1 over R, we're supposed to find this, right? Equals to 1 over 3, agree? Plus 1 over 6, agree? 1 over 3 plus 1 over 6 is how much? Mathematics, genius, everyone? Times 2 times 2, correct? Which gives me 3 over 6. Agree? Which gives me 1 over 2, correct? Anyone got 1 over 2 ohm as a final answer? Yes, no? Who else? Yes? All of you. Okay, students who gave me 1 over 2 is incorrect. Very good, Zenyi. Answer is 2. Why? Hello? Hello? All right, even if 1 over 2, I understand. Remember, this is 1 over R. Resistance is just R. 对吗? So you have to flip it upside down to give me R over 1, not 1 over R. So if I flip it upside down, I get R. If I flip the other side, I get 6 over 3, which is 2 ohm. 明白吗? Oh, yes lah. Good. I like that sound. You'll say, oh, that means it lights up something in you. Okay, it triggers a awakening there. All right, so back to the first question. Whose total resistance is higher? Max, whose total resistance is higher? C, A or B? Right. So you see, if you go through series, you have to fight 3, you have to fight 6. You have to fight a total of 9. Right? But when you write here, you fight 3, sometimes you will fight 6, but on average, you fight 2. Understand, not? Yeah? Okay. Now, homework, try this one. Lights up more brightly. Means what? Okay, you can rewatch the recording and see I did mention something about brighter and not bright. What does it mean? What am I calculating? Take time. and do for this homework. Can or not? Cannot. So let's just do some exercise on resistance, shall we? Okay. On this screen over here, I will give you a drawing. You all will calculate total resistance for me. Students, look here. Please calculate my total resistance of this parallel circuit. Let's see who can find for me first. Bro, hey, this is not even the start yet. This is not even the start. This is just level 2. 9 nah. How dare you tell me it's 9? Huh? I drive all the way to Puchong and find you, I tell you. I make you do resistance formula for 3 days, 3 nights, I tell you. I still remember. Okay, I know. Impossible you tell me it's 9. Okay, go. I got 8 more minutes. Let's see, first person. Take out a piece of 飞纸 and write somewhere, okay? No need to draw, just take a 飞纸 and do. Because I got another question coming up. So fast. Wow, Zenyi, okay, she gave the first answer. I don't know yet. Actually, I still don't know. I'm just putting numbers in. Yeah, we count together lah. It's not too hard. Hey, am I on loudspeaker, Dylan? Wow, 1.083. Okay. Okay, let's see what speaker. Asking, am I on loudspeaker? 0.92. Wow, so many answers in this class. I got 4, I got 0.92, I got aura, I got wow, so many answers. Okay, let's see what is the correct answer. Okay, let's start. 1 over r is 1 over 2 plus 1 over 3 plus 1 over 4. Correct? All happy with this? Find the common denominator. What's the common denominator? Should be 12. Correct or not? Times 3 times 4 times 6. Correct? You get 12 at the bottom. So times 6 times 4 times 3. So what do I get in total? 1 over r is 6 plus 4 is 10. 10 plus 3 is 13. 13 over 12. Agree? This is 1 over r. So if I flip, will be 12 over 13. Okay, 12 over 13 gives me a 0.92 or 0.923 ohm. Those who got 0.92, you got it? Okay. Next level. I'm going to erase this level over here. Oh, wait for what? Wait for Chinese New Year. Let me upgrade here to 2 and 2. But I will erase this away. Okay, forget to multiply. Hiya. Okay, next level. Guys, look here. This is under series circuit already. These two only. These two is a series, correct or not? So what's the total resistance here? So it's no longer 2, it's no longer 1 over 2 only. So this is how much. So calculate the total resistance for this now. For the whole circuit, everything. Oh, so fast you answer. Wow. Zhenyi answers up already. So let's see. First one. 这里 total series. If series, you add them up together first. 对吗? 2 plus 2, you get 4 ohm total for this circuit. 1 over 4 first. Agree? Second one, you get 1 over 3. So times 4 times 4 times 3 times 3. 3 plus 4, you get 7 over 12 is 1 over R. R is 12 over 7, which gives us 1.71. Zhenyi, congratulations. Genius are you. Okay. Understand not? Level 3. This one, I let you go home and figure out yourself. Are you ready? Okay. I'll screenshot it. All right. Ready? Calculate the total resistance of Am I giving too much? No, right? Okay. Let's go. Okay. Can lah. This is just a test only. Okay. Maybe I pull one more here. Okay lah, the one lah, cukup lah. Okay. Yeah. So you see here, think how for this circuit is 1 over what? You have to figure this one out to figure the total of this, to figure the 1 over. Same concept like just now. Okay, it's the same concept as just now. Like I say, this one is not a homework. This is just a challenge. For those, I know there are smart students here who likes to be challenged. So this is for you. If you don't want to do, I'm fine with it also. Okay, calculate what? Total resistance of this circuit. This is quite simple. Okay, even last year, I haven't opened up another one where I open, okay, 2 more coming out from here and then join. I don't go there. Okay, this is good enough. Yeah, so you have to do like, figure one small part to add up to add up. What Max so fast? Okay, Max give me 0.75. Okay, show me your reading. You screenshot this one right now. Okay, and then after that, write your jalan kerja and show me your screenshot of your work. Okay, can? Again, this is not priority. Priority is the rest. This is just challenge. Okay. All right. So thank you, students. I'll see you guys next week, same time, same day. And you may unmute yourself and say your farewell. Have a good remaining holiday. Bye-bye.
Thank you, Kenny. Bye-bye.
Bye-bye.